In today's video, we are going to be making a simple 2D platformer in Unity. So we've got our little player man, we can jump, we can shoot, our little AI snail guys, and we've got a camera that follows the player around as they move around the scene. Quick disclaimer, what this video is not is a quick 5-minute video, as you can see by the time it's going to take. I don't know how long it will take to film this, but it will probably be over half an hour long. So if you're looking for a 5-minute thing, this is not for you. My aim is to teach you how to do things without the need of tutorials going forward, and 5-minute videos generally don't do that. It is also not a video that will contain everything in one script. There are lots of scripts because that is the right way to do things with Unity's component system. So if you were expecting one simple script and everything to just work in a couple of lines of code, then this is probably not the video for you either. If you're brand new to Unity, I would suggest starting with the Flappy Bird tutorial I made, because in that video, I'll teach you everything, what the editor looks like, how we use it, what the hotkeys are. In this video, it's going to be a bit more advanced. I'm just going to talk about concepts more than anything, and I will expect you to have a bit of a better grasp of the Unity editor and how all of that works. If you would like to download the source code, it is available to all of my Patreon subscribers. Thank you guys so much for all the support. You are the best and you are keeping me going. With that said, let's dive right in. All right, so we're going to create a new project here. It's going to be a universal 2D project. I don't want this to be a cloud project, so I'm just going to say create a new local project, and we can call it alien shoot snail. First thing I'm going to do for once, usually we would gray box this part, but I'm going to bring in some assets because it's more fun to work with things that look nice. So we're going to get this asset from Kenney.nl. Thank you, Kenney. You are a legend. So I've already downloaded all of this stuff. So I'll leave a link to this pack in the description. You can go get it if you would like. So I've downloaded all of those assets, and I'm going to bring a couple of them into our game. So the first thing I'm going to do is I'm going to create a new folder, and I'm going to call it art. And then inside of the art folder, I'm going to go bring in all of the things I want. I have no idea what tiles double means, so I'm just going to use tiles default and bring that in here. I'm going to use characters default, and I'm going to use enemies default. Okay, then for each of these, I'm just going to go take a look at them. It's already brought it in as a Sprite 2D and UI. Oh, by the way, we're going to be using the new Unity input system. So if you're getting any errors about active input handling or confusion between using the old and the new Unity input system, you can just go to Edit, Project Settings. Then you can go to your player settings. And here where it says active input handling, just make sure this is set to both, and then you shouldn't have any input handling errors. Okay, so first things first, let's draw some tiles on the screen so that when we add a character, we can put them on some ground. So I'm going to open the sprite editor here for our tiles package. I'm going to slice this up. I'm going to use grid by cell size, and 64 seems to be pretty good. So I'm just going to slice those up. Then I'm also just going to name the tiles I plan on using, because otherwise they have weird default names and it's hard to find them. So I think I'm just going to use these as the basic platforms. So I'm just going to call this like platform middle. Oh man, you can't see me naming that. Let me move my face out the way. Boop. Okay, yeah, so I'm just renaming this to platform middle. And then we'll use this to platform, because this is the middle, the end piece on the right and the end piece on the left. So platform, we'll call this right. Platform end right. Name this whatever you want. This is just naming patterns that I think help me find things more easily. So platform end left, and then I will apply those changes. Cool, so now we can close the sprite editor, and what that gives us now, if we expand that out, then we have a whole bunch of different tiles, which we can rename if we want to, but nobody got time for that. So I'm just gonna use these. So now what we could do is we could start dragging on some tiles, and yeah, that's a bit of a pain. Oh man. So that would be a bit of a pain to do. So instead what we're going to do is we're going to use tile palettes. So a tile palette just makes it much easier to draw on a bunch of tiles into your scene, and it stores that in little tile file data. And it stores that data in little files. I'll show you more now. So to use tile palettes, we can go to create a new 2D object, and we'll go to tile maps and rectangular. This will create us a grid and a tile map. Perfect. So we can leave that at the default settings, and then we can go to window, 2D, tile palette, and then this gives us this little window, and we can dock this over here so that it's easier to access. And then we can create a new tile palette using our tiles. So I'm just going to call this tiles and say create, and make sure to store this in a folder because it creates lots of little data files. So tile, I'll just call this tile data and choose. And then I'm just going to drag in. So you could drag in this whole thing and then you'd have access to all of the tiles, or you can drag in some of the tiles and let's make sure we use our tile data. And then this will give us the ability to just select whatever tiles were in our sheet, right? So now the power of this is we can just grab this, and whilst we have that selected, we can just draw tiles in, which is way easier. Now, as you can see, we have a bit of a gap here, which is okay. We can just go to our grid and we can reduce the cell size to like 0.64 or whatever works till it fits. Then we can select an end piece and we can put that over there and another one over there. And we want to create some height so that we can test out our jump once we create it. So we'll put this here, we'll put this here. And there's a bunch of different like brushes and modes you can use for this. Like here we've got an eraser, so I can just erase that because I think it was a bit too high. And we've got this. Cool. And then we'll put one more like here, an end piece there and an end piece here. Cool. And I think that should be plenty for a start. Then we want to create a character. So to create our character, we can look at our characters sprite sheet, and again I'll open the sprite editor, and in here I'm just gonna select like, I don't know, maybe the first 3, and we'll create our character out of that. Okay, I just wanna, so let's rename these again to character like 01, character underscore 02, and maybe character underscore 03. And yeah, that should be cool. So I'll just apply that so that I've got the names of those characters down. And then all we need to do is we select the frames of the animation we want. In this case, it's character 01, 02, and 03. And then we just drag those in. Now this is going to ask us where we want to store our animation file. Because we've selected 3 character frames, it's going to create an animation file for us. So all we're going to do here is in the assets folder, I'm going to create a new animations folder, and I'm going to call this character.anim, and that's going to save us a little animation file. If we turn off our gizmos, we'll be able to see that our player is there in the middle and he looks pretty good. And because we've done that, because we've dragged it in that way, it's automatically created us an animation controller and an animation. So if we were to open that animation and select our character and hit play, then we can see our little animation playing in a loop, which is perfect. Rightio. So the next thing we want to do now is we want to get to controlling or adding some physics to our character. So to do that, we can create a to our character, okay, which I'm just going to rename also to character, and let's enable the animator, and I'm going to add to this a rigid body 2D and okay, I'm going to add a box collider 2D here, just to show you an issue you can have when you're using box colliders and why it's usually better to use a capsule collider, right? So now that we've added a rigid body, it means that our character will obey some Unity-based physics. So in this case, gravity is enabled. That means when we press play, the players should fall, which they do, but they fall straight through our platforms. So to fix that, we can come to our tile map inside of our grid, and we can add a tile map collider 2D game object component, sorry. And this will add colliders to each of our platforms. So now if we press the play button, then our character falls and lands on a platform, which is a good start. Okay, so the next thing we want to do is let's get to writing some character controller code. All right. So in our assets folder, let's create a new folder. We'll call it scripts. And inside of our scripts folder, the first thing we're going to do is we're going to create a player input handler script. And this script is going to be in charge of taking in player input and passing it to our character controller. So the next thing we're going to need is a character controller script. So we'll create a new script and we'll call it character controller. All right. And the reason we don't put our player input directly inside of our character controller is because we want to reuse our character controller for different characters in the game. It's not just our player that we need to think about. When we add our AI players in, we want to use the same character controller, but we just want to use a different script to handle the input for AI. I'm using Rider, which has been pretty damn awesome. Thank you to Rider for the license. Okay, so the first thing we want to do in our player input handler, because we're using the new Unity input system, is we want to add a using to that. So we can say using Unity engine.input. Wow, it's like the AI heard me. And guys, AI, totally good up to a point for helping you learn. Just be careful with it because it spits out a lot of crap a lot of the time. So you just need to make sure that you're double checking what it says, that you're referring to the documentation, because Unity's documentation is the truth, not what ChatGPT says. I've seen so many comments on videos where people are like, no, but your code is wrong. But it's because the AI gets confused between the different versions of Unity, and I usually use the documentation as my point of reference, not what ChatGPT says. But I do use it occasionally. You'll see we can try to use it a bit in this tutorial. All right, so anyway, with that out of the way, now the new Unity input system is really easy to use. All we need to do is we'll declare some variables here. So we want input actions, and we want our move action, and we want a jump action. And these actions, you can find them defined in the new Unity input system. If you come to Edit, Project Settings, and we come to Input System Package, then here's all of these actions that I am going to be referring to. So there's our move, there's our jump, and eventually we'll use our attack. Okay, so now that we've defined our move and jump actions, in our awake function, we want to actually assign values to these. So to assign the actual move action, we can say input system dot actions dot find action, and we want move, and then we can say our jump action equals input system dot actions dot find jump. Thank you to Rider for auto completing all of that. And then what we're going to do here is, because the jump action is a button press, which again we can see by looking at the type of action that is defined here. So the move, for example, its action type is a value, but its control type is a vector2, meaning that when we read the value, we're going to get out a vector2 value representing the x and y of the input. But when we're using the jump, it's a button. So instead of that, we can use an event. So to use an event, we can say jump action dot performed, which is just a C# event. And then we can bind that to a method. So when the jump action dot button is pressed, we want to call a method called jump requested. Or we can actually just call this method jump. Okay. And then we need to actually define that method. So we'll say private void jump, and it needs to take in a parameter of type input action dot callback context. And this will be called context. And we'll do something with this in a little bit. And also, now we're going to have our update function. And in our update function, we want to read out the value of the movement input. So what we can do for that is we can define a new vector2 variable called move input. And here we can say our move action dot read value vector2. And we're gonna pass these values into our character controller in a moment. So all this is doing is it's reading the value of the move input each frame. Okay, I'll move my face out of the way again. Yeah, so it's reading the value of the move input each frame. So the move input will read like A and D as your key presses on your keyboard, or the left and right arrow as the values -1 and +1. Cool. Now, let's open Unity again. Now we want to start defining our character controller. Okay, so in our character controller, what we want to do is we're going to be affecting the player's rigid body. So we want to define a rigid body 2D, and we'll call it rigid body. And then in our awake function, we want to actually assign that. So we can say rigid body equals get component rigid body 2D. So this will just get the rigid body from our character, from our character game object, which we created earlier. So if we look at our character game object, which is over here, then our character game object has this rigid body. So when we call get component, we're just going to fetch this component from the character. Cool. Alrighty, let's get back to coding. Now, what we want to do is we want to create a public function called move that takes in a vector2 with a public function called move that takes in a vector2 move parameter. So this is what we're going to be calling from our player input handler or from our AI script, our AI input handler later. And this is going to actually tell our character to move. So what we can do here is we can store this variable private vector2 underscore movement vector. The reason we don't just want to update it there is because we want this to happen in fixed update because we're affecting physics. So instead of just calling rigid body dot linear velocity x here, we're just going to rather store this value in the movement vector. And then we're also going to create a public void jump function. And here we're going to need a Boolean variable called jump requested. Okay. And then we're just going to assign here jump requested equals true when this function is called. All right. So now in our player input handler script, we can add a reference. Let's serialize this so that we can assign it in the editor. So we're going to say serialize field, private character controller, underscore character controller. And now in our jump function that we created earlier, we can call character controller dot jump. And here in our update, our move input, we can call character controller dot move and call the move input. Perfect. Now in our character controller, what we can do is we can define our fixed update function, right? And this is where you want to handle physics-based things. So in here, we can just call rigid body dot linear velocity x equals, okay, we want it to be our movement vector dot x, but we want to multiply this by some kind of movement speed so that we can change how fast the player moves. So let's go up here, and this variable we're going to actually serialize so that we can change the values in the editor. So we'll say private float underscore movement speed equals 10f is a good start. So there we've got that. working now, and we can test that this does what we're expecting. So let's go into Unity. All right, and now in our character, let's add our character controller component that we added, as well as our input handler, player input handler component that we added. And this needs a character controller reference, so we can just put that in there. We could have also done a get component here, but dragging it in works just fine. So let's hit play and see what happens. Whoa, okay, so he moves from left to right, but the player now is rotating. So we can fix that simply by going to our rigid body and adding a constraint and freezing the rotation on the z-axis. So this way our guy won't fall over. He'll fall and then he'll move. So now we've got a bit of an issue where he moves from left to right, but he's getting stuck, and he's actually getting stuck on these colliders. So this tile map has these little colliders, and because our character uses a box collider, he gets stuck on the little edges of the tile colliders. So we can fix that by just changing this guy to, instead of using a box collider, we can use a capsule collider 2D. And I just want to change the radius of the capsule collider to make it a bit smaller on the X, because we don't want our player to die like if they just accidentally touch something, you know. It's got to be fun. All right, so now our character, because he's using a capsule collider, he no longer has the issue of being getting stuck on those little platforms, but he does move really fast. But thankfully, because we serialized that field, we can just fiddle around with the movement speed. Oh no, is my face in the way? Oh, need just not. I'm gonna make my face smaller. Okay, so yeah, I'm not sure. You may have missed the part where I added the capsule collider 2D. But essentially, I just deleted the box collider and added a capsule collider 2D component instead. And now we've just reduced the speed to 5. So that feels much more bearable. The only thing though is, what the heck? Okay, so this guy is getting stuck on platforms, but we'll talk about that in a moment. So now, because Unity doesn't keep track of the values after we stop the game, so just remember to come in here and set your movement speed value to 5 when you're done. Cool. So I don't really like how close our platforms are, so I'm just gonna make some modifications here. I'm gonna delete this platform and maybe just create, I'll just go to this brush. Maybe I'll just move it over to like here rather. Boop. That should be a bit better. So now we can at least like move our guy around in peace. Okay, cool. So he falls and that's cool. Now this issue of him getting stuck on the side of platforms, that is annoying. So what we can do to fix that is Unity has us covered with something called a platform effector 2D. So platform effector lets us change the way that characters interact with platforms. So for example, we can use something called a surface arc to make it so that the character, we can use the use one way toggle to make sure the character can or can't go through the bottom of platforms, for example. So in my case, I don't want to use one way. I want him to collide with the bottom. Don't want to be able to jump through because we're making the next Hollow Knight Silk Song out here. And to make this work, you just need to add the platform effector, change the settings you want, and make sure that in your collider, the used by effector toggle is set to true. And that should be all you need to do. Now, as you can see, our guy no longer gets stuck to the side of platforms. Perfect. So the next thing we'll do is let's work on adding a jump. So I'm going to open up our character controller script. And now what we're going to do is we're going to say in our fixed update script, man, moving my face around is like the bane of my existence. All right, so in our fixed update script, we're going to say if the jump was requested, then we're going to want to set the player's linear velocity on the y-axis by some jump velocity. So let's add a new float variable here called jump force. And we'll also set this to 10f. And then in here, we can say rigid body dot linear velocity y equals jump force. So this also is up to you. I prefer this kind of jump because it will, every time the player jumps, it will set their velocity to 10f, so it'll be like a brand new jump. But if you wanted to, you could use add force, but then the force of the jump will feel less as the player is falling. It all depends on what kind of feel you're going for in your game. So I'm just gonna use this for now. And then we can set here the jump requested to false. All right. Now, if we go back to our game, now we can jump, but he jumps so high and he feels really floaty. So we can fiddle with some of the values to see what we like. Something I like to do is I just like to increase the gravity scale, maybe to like 3, and then that feels a lot better. Boop, and then he can jump as much as he likes. Yeah, that feels pretty good. So I'm just gonna copy that value or whatever, just enter 3 after we press stop. I'm also going to close our tile palette because I think we're good for now. And when the game starts, I want the character to start like down here, so I'm just going to move them over there and hit save. So now, I mean, we could add like a simple double jump counter where each time the player jumps, they can we can increment a counter and make it so that they can only jump twice. But our character seems to be themed with like some kind of helmet thing on. I don't know what Kenney was going for here, but it looks pretty cool. And if he's a space character, then he should be able to jump as much as he wants. So I'm going to leave it at that for now. And the next thing we're going to do is we're going to get started on, let's add a camera follow solution. So we could write code for this, but instead I'm going to use Unity's Cinemachine package. So to do that, let's go to Package Manager, and we're going to search in the Unity registry for Cinemachine, and we're going to install it. And this thing makes camera follow scripts kind of redundant unless you're going for something very specific. But you can achieve most results with this these days. So once we've installed that package, then we can just go to Game Objects, Cinemachine, add me a Cinemachine camera. Actually, there's better options. So we can go to Game Object, Cinemachine, Targeted Cameras, and then you can use like a 2D camera. And this we can say is like the character camera. And here we need to give it something to track. So we'll just drag in our character into this tracking target. And now our Cinemachine camera will track the target. If we look at it from the game view, it will show you this nice little crosshair. And if we want it to be a bit closer, we can reduce this value on the lens, and that will bring it in closer or further. And then if we hit play, it's literally as simple as that. Now we have a camera that will follow our player around. As you can see, the camera delays a bit before it starts tracking the player. If you want that to be more or less, then you can affect the damping. So if you look at the target tracking down here on the right hand side, my face is always in the damn way. Then we have this damping option. So if we were to change this value to 0, then the camera wouldn't lag behind our player at all. It would follow us exactly. So I had a damping value of 1 on Y, but if we remove that or make it 0, then it will follow it exactly. But it looks really nice, I think, if you have like a slight damp on the camera. And boom, that's really, really cool. Right, so camera follow done. Now, the next thing that we should do, what should we do? Let's make it so that we can shoot some stuff. So to shoot stuff, we're going to use a very simple approach. We're going to create a weapon script. So we'll call this weapon. The reason I say this is simple is because this is where things can start to get really complicated. The actual way that I would do this if I was trying to write a full-on game is I would write an inventory system. And inside of the inventory system, I would have equipable or non-equipable items, and when the player tries to attack, I would look in the inventory to see which item was equipped, and then based on that I would attack using that. But for the purposes of this tutorial, we're just going to keep it simple, and we're going to say that the player is going to have a weapon, and then in our character controller we're going to have an attack function, and when the attack function is pressed, we're going to check if there's a weapon component available, and if so, then we're going to call the attack function on that. All right, so first things first, let's open our weapon. And in our weapon, we're going to want to do some things. We're going to want a public void attack method, right? And then what do we want to do when we attack? We want to spawn up a little bullet that moves in the direction that we're facing. So to do that, we can say we need a reference to a bullet prefab. So we'll go create this in a moment, but we want a private game object underscore bullet prefab, right? And then we want to instantiate that. Instantiate our bullet prefab, and we want to do that at our transform.position and our default rotation, which is quaternion.identity. Okay, and now we actually need to go and create this bullet prefab. We can go ahead and create a new game object. It will be a 2D circle sprite, and we shall call it bullet. I'll just reduce its size a bit till there. And to it, we're going to add a rigid body 2D. We're going to change the gravity scale to 0 because we just want this thing to move left to right based on the player's direction. We can freeze the rotation. And cool. Then we're going to need a bullet script that controls the current velocity of our bullet. So we'll just create a new script and we'll call it bullet. We'll open it up. Inside here, we're going to create a new float variable. I'll call this private float underscore speed. And this will be 10F is a good start. And then we're going to want a reference to the bullet's rigid body. So we can say private rigid body 2D underscore rigid body. And in our awake function, we're going to get our rigid body from the game object. So we can just call get component rigid body 2D. And then in our fixed update method, we're just going to say our rigid body dot linear velocity dot x is going to equal. Now here comes something interesting, and we need to figure out which way we want our bullet to move. Is it going to be moving left or right relative to the player? So to do that, what we can add is let's create a let's create a private vector2 direction. Okay, and then what we're going to do is we're going to create a function called initialize, public void initialize. So now when we spawn in our new bullet from our weapon, we're going to call this initialize function, and we're going to tell it which direction it needs to move. So in here, we'll take in a vector2 direction, and then we can set the direction equals to the direction that was passed in. And then here we can say our linear velocity dot x should equal our direction dot x multiplied by our speed. Okay. So now let's do this. In our weapon, we know that our game object that was instantiated is going to be a bullet game object. And from it, we can get our bullet component. So we can say bullet equals bullet game object dot get component bullet. And then we can call our initialize function, right? But now what direction do we pass in here? We don't know. We need to get that from our character controller. So let's, in our attack function, we'll add a parameter called direction. and then we will just pass the direction into our bullet. So when our bullet is spawned in, it will get initialized and it will set the direction to whichever direction was received from the character controller, and then it will move in that direction consistently. So now we can just go to our character controller, and in here we want to add a public. Let's move this to where the other public functions are. Okay, yeah, that's fine. So let's add public void attack. And in here, what we can do is we want to then call our weapon. So let's create a private weapon underscore weapon. And then in our awake function, we can say our weapon equals get component weapon. And then if our weapon is actually assigned, because remember, if it fails to get the component, this will just be null. So we can just say if our weapon is not null, then what we want to do is we want to call weapon dot attack. Now, which direction do we want to move in? We can actually just, sorry, my dog is barking and stuff. Not sorry. Private, so we want to keep track of the last direction that the player was moving, because at the beginning, this value is going to be 0. And every frame, if the player is not pressing any input, then the value is still going to be 0. So the thing is not going to move anyway. So we want to say private vector2 underscore last move, last move direction, I guess. And we can just say vector2.right is the default value. So if the game just starts in and the player presses the shoot button, then we can just spawn the bullet moving to the right. And then in here, we're going to attack using the last move direction. And then in here, we just want to say when the player moves, if the move vector does not equal vector2.0, so if there is actually some left or right input, we actually want to make this, if the movement x value is not 0, then we want to store that value, because otherwise the player could press like up or down and then our bullet would move up. So I mean, it might be valid in some games, but for me, I just want the player to be able to shoot left and right. So that's why I'm going to do it this way. And then I'm just going to say whoopsie daisies, last move direction dot x equals move dot x, and that should be good. So now when the attack method is called, we check if there is a weapon, and if there is a weapon, we call the attack and we pass in the last move direction, whose default will be right, unless the move input has happened, in which case it will be -1 or 1. And then this, if we follow this track, will come in here. It will spawn in a new bullet game object, and then it will call the initialize function on that bullet game object, on the bullet component rather. It will set the direction that we passed in. Let's move this awake up to the top. And it will update the rigid body's linear velocity on the x-axis in the fixed update function based on the direction multiplied by the bullet speed. Perfect, I think. So the last thing we need to do is in the player input handler, we need to add an action handling for our attack action. So let's call this one attack action. We'll call this attack action equals input system.actions.find action attack. Okie dokie. And then we can say attack action dot performed plus equals attack. And then we need to define our attack method. So we can say private void attack input action dot callback context. And here we can say character controller dot attack. Cool. And I just want to double check that that is actually the name of the action in Unity. So we can go to our edit, project settings, attack. Okay, cool. So now we have our bullet with our rigid body. We need to actually add the bullet script onto this. We'll save that. And then we want to do a couple of things here. We need to add a collider to our bullet also, so that it actually collides with things. So we can say this is a circle collider, but we're going to use a trigger here rather, so that it doesn't actually like knock characters back or anything. It will just, as soon as it enters another collider, it will fire a method that we can use later on. But for now, we've got enough to test it. I'm just going to add that in. But what I want the collisions to do is to exclude the player. So I need some layers here so that we can avoid collisions on certain things that we don't want there to be collisions on. So for example, our character, we want him to be on a layer called like player. And then we're going to add enemies just now. So we can add a enemy layer and we can add a ground layer. Okay, because we want our bullet to be able to collide with like the ground and the enemy, but we don't want our own bullet to collide with ourselves, right? So then what we can do is we can include certain layers. This is another feature that was not in previous versions of Unity. So if you're not seeing the layer overrides, it's probably because you're in a different Unity version than me. So in the includes layers, I'm going to say we want this to be able to collide with enemies and with ground, but we don't want this to collide with player. Okay, let's say we don't want it to collide with everything except for the enemy and the ground, right? So that should be good. And then we just need to create a prefab out of this. So I'm going to create a new folder here. I'm going to call it prefabs. And I'm going to drag our bullet in here. And then I'm going to delete it from the scene. And now on our character, we can add in our weapon, right? And our weapon needs to have our bullet prefab. So I'm just going to drag that into there. And hopefully we are good to go. So let's press play and see what happens. So now we can move around. And then when we press the shoot button, our bullet shoots in the direction that we last moved. Woo! And that is really cool. Let's create an enemy. So we're going to go to our enemies sprite sheets and let's open the sprite editor. And we're going to use our little snail guy here. So we'll call this snail01. And we'll call this snail02. And we shall apply that. Move over here. And then we'll just drag in snail0. Oh, we need to be in the scene view to do that. So we'll just drag in our snail over there. And remember, it's going to create an animation for us. So we can rename this to snail.anim. Save that in there. Cool. And then to this guy, we want to add a couple of things. Okay, we know we want a character controller. It's not our player character controller, but it's a character controller. We just need this guy to move left and right, which is perfect. And then we need to add a circle collider 2D to him. Okay, we'll probably reduce the radius so that he doesn't, so that the collider doesn't seem like it hits too easy. He needs to have a rigid body 2D with a frozen Z rotation, and he needs to be on the enemy layer. Okay, cool. So before we get to our bullet, actually, let's work on our bullet because that's what we're busy doing. So we'll get to the character controller situation in a minute. For now, I'm just going to disable that. So if we hit play, then we should just have our little animated snail just standing in one spot, and that's pretty cool. So now the next thing we want to do is we want to get to a point that our bullet actually does something when it hits our snail, right? So to do that, let's open up our scripts. And what we're going to want to do here is we're going to want a health script, right? So the health script is going to be able to take damage. So it defines how much health everything has. We could use the same script on our player or on our snails or any other enemies that we create. So all we want here is we want a serialized field, private float underscore, yeah, I guess an int could work also. So int, thanks AI, int max health, and we'll set this to like 30 as a default. Well, obviously we can't convert to float if we are using that. Cool, and then we will create a private int current health, and then on start we can say our current health equals our max health. And then we also want a function here called public void take damage int damage, and then we want to say current health equals mathf dot max current health minus damage 0f. So this will give us actually, yes, you know what, I want to use float, so I'm going to go back and I'm going to change this to use floats, because our mathf functions use floats, but you could probably use an integer here. So no, I want us to use float. So let's use private float max health equals 30f, private float current health, and then our take damage function should take float damage, and then this will be the maximum of these two things. So if the health dips below 0, it will default to 0 anyway. And then here we just want to say if our current health equals 0, then we want to destroy our game object. Cool. And then what we want to do in our bullet is, because we've made our bullet a trigger, we want to say on trigger enter 2D, we want to say health equals other dot get component health. So the thing we've collided with, if it has a health component, so we want to check if health not equals null. If the thing we've collided with has a health component, then we want to deal some amount of damage to it. So let's create a new variable called damage amount, and then we will say serialize field private float underscore damage amount equals 10f is a good start. So now every time this thing collides with something that we have defined on the layers we used earlier, provided, yeah, so once it collides, provided it's on the layer, it will look for a health component on that thing that it's collided with. And if it has that, it will call the take damage function, which we just defined here, which will then go deduct the health from the current health. And if it's 0, it will destroy the game object. Cool. So let's hit play here and see what happens. Well, we can move from left to right and we can shoot. Oh, and this goes straight through our character. Why is that the case? Let's go see our prefab, our bullet. What's your story? Okay. So this should be good. Oh, okay. Also, so we want to actually destroy our bullet also on trigger enter so that we know that it's actually collided with something. So let's go to our bullet on trigger enter, bullet destroy game object. So our bullet should actually be destroyed when it collides with anything. So let's just go check if this works. We'll go back here and we'll press play. So if this doesn't hit anything, okay, so it is hitting stuff. Is it hitting our snail? It's definitely hitting our snail. So the problem is we haven't actually added a health component to our snail yet. So let's fix that real quick. So we'll go to our snail guy and then we will say, please, can you have a health component? And your max health is 30. So now if we jump and we shoot, then we hit him 3 times and he dies. Woo, success. Okay, cool. So now the next thing I want to do is I just want to create a prefab out of the snail because we want a couple of them. Let us go here, add our snail in here, and we can add a second snail over here. Alrighty. So the next thing we want to do is we want to add some AI to our snails so that they move from left to right. And just looking, this video is already 55 minutes long. So I think I'm going to call it here. If you would like to see how to add the AI for the snails, please leave a comment down below and I will make another one of these videos. I've actually had a lot of fun doing this. So hopefully you've learned something. And again, if you would like the source code, it's available on Patreon. Thanks so much for watching, and I'll catch you on the next one.